Hi all. So today we are going to solve this very interesting problem, which is sum of distances. So in the question you are given a zero indexed integer array nums. There exists an array ARR of length nums length where ARR of I is the sum I minus j mod over all j such that nums of j is equal to nums of I and j is not equal to I. If there is no such j, return ARR I equal to be 0. Return the array ARR. So here you are given integer array where there could be a repeating elements. So in case of there are repeating elements, then you need to uh, get the sum of all the distances. So for this position, the zero index position, so the position at which the same elements are present here, we can see is 2 and 3, right? Index 2 and 3. So the sum is 2 minus 0 plus 3 minus 0, that is 5. And similarly, if this is like a unique element, then it is 0. Directly we can put. If it is uh, again, so here we are checking the 1 again, and the distance from the 0th index position to here is 2, and distance from the next element here is 1. So 2 plus 1 is 3. That is what written here, right? So I will walk you through another example that I have written here, and we'll find out what is the optimal way to solve this problem. We are thinking is to keep a list of all the occurrences of this element, and like whatever is repeating and non-repeating elements, we will be keeping a list of all the indexes where the elements are present, and then we'll try to find out the uh, distances in very optimal way. Yeah, so what we are going to maintain is a map. So let me write down here. So for element, so for this array, let me write down here 2, 1, 1, 3, 5, 1, 1, 3, 2, 2. And the indices are 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for element 2, we have indices 0, 8, 9 present. Now 0, 8, 9. So we can maintain a list of it and map to the element itself. So for similarly for 1 we will have 1 is present at 1, 2, 5, 6, and similarly the other elements, right? So we will closely observe what we can find out through these two examples, and we'll derive a formula to calculate all the distances most optimally. So for example, this example, we have 0, 8, 9. So how we are getting the distance? So that is 0 minus 8 plus 0 minus 9. So if you see, the things which are on right side will always be greater than, because the first index itself, right? Because we are always increasing the element while storing all these indices. So we can always put the, for absolute value, we have to get this in positive, right? So we can ensure like whatever on the right side of this indices, we can keep it in left side of this operation, and 9 indices. So yeah, so we can put all the right things on the left side. Okay, why I'm telling you this, because when we try and through this example, we will find out the formula for it. Okay, and so one thing to observe here in this is like this list can grow really high. As in, if all the numbers are same, then this list length would be same as the length of the given array nums. So in that case, finding out the distance from for each element, it would we cannot iterate over each element again and again. Otherwise, it will take the time complexity as O of n squared. That is the worst case time complexity, and we want to avoid it. As in the constraint, you would see the time the ranges are really high. That is 10 to the power 5, and this will go 10 to the power 10. That will give us time limit time limit issues. Yeah. So in order to do it in optimal way, we need to try out extract some formula through which we can identify this in probably O of n or log, like n log n, maybe something. So here it is already sorted. So we can see that all the indices on the right side are greater. So while getting the absolute value, we can put those values on the left side of this equation, right? And then we are finding out the sum is 17 here, right? Now, uh, for position 8, it would be again 0 minus 8 plus 9 minus 8, right? So whatever on the right side, we can put it on the right itself, right? And whatever on the left side of this would be like a lower value, right? So this sum would give negative, but we need to find the absolute of it. So we need to do 8 minus 0 here, and this one is become 1, and this 8 minus 0 will become 8. So the value becomes 9. So you would see for second occurrence of 2, the value is 9. We are getting it, right? So let me dry run through this uh, example as well, through which we will get the formulas extracted again. So yeah, so for element 1, what do we have here? The position of all the indices, that is 1 comma 2 comma 5 comma 6. Now we need to get the absolute sum of it in some optimal way. So for this position, if we see, all the positions we are going to evaluate will be on the right side. So we can do something like this, like 2 minus 1, we are going to the larger element on the left, plus 5 minus 1 plus 6 minus 1, right? Now we can take this minus 1 common from all these three. So minus 1 into 3 plus 2 plus 5 plus 6, right? Also, if you see, this is minus 3 plus, and this one is the sum of all the elements on the right side. So if we keep some post sum here, so that would store 6, 6 plus 5, 11, 11 plus 2, 13, right? So we can directly get this value 13 here in a constant time for this, and get the number of elements on the right side. This also we can evaluate in constant time, and minus 1 is the, so 1 is the value, and since we are calculating all the things on the right, we need to do a negative 1. So this would come as 10. So that is what the position for this one is, coming as 10, right? Now for the second position, if we see, we have one element on the left. So we know this element is going to be always smaller than the current element. So this we can write as 2 minus 1 plus, now we need to find the distance of all the right elements. So for right elements, it would be 5 minus current element plus 6 minus current element. So from here also we can say that for the left part, what we can do is we can take 2, that is the current index, and that is we have taken 2 common, and we are left with minus 1 here, right? So 2 into 1 plus, so only one element is, since it is common, then we need to just add minus 1 here. That is what remaining. And for the right side positions, we can take minus 2 into 2 elements are there. So 2 and then 6 plus 5. That is the sum till here, right? That is 11. we can take this in constant time from the postfix sum, and we will get a value of 1 here, plus for the left part, and for the right part we would get, so this is plus here in between, minus 11 minus 4, that is 7, and the value will become as 8, and that's what we see here, right? For this second position, second index, we are getting this value. Okay, so let me get this one also, and then we will move to the code. So for this position, we see that we have two elements on the left. So 5 minus 1 plus 5 minus 2, and one element on the right, that is 6 minus 5. So here we can take 5 common into number of elements which are on the left side is 2, and then plus what we have is here minus 1 minus 2, that is minus of prefix sum of these two elements. So that is the prefix sum here. So the prefix sum is 1, 3, 8, and here 14, right? So we can get the prefix sum in constant time here, like 3, and this is 10. For the right hand side part, we can simply do minus 1 minus 5 plus postfix sum of the right element. So that is 6, right? So if we evaluate this, we will get 8, and that is what our answer is here. So we derived this formula to identify uh, the values in constant time. Otherwise we would have to iterate it again and again, and that would increase the time complexity. So the formula looks like something here in number of left elements into current index, current index plus minus, this is minus, and prefix sum of this current index position minus 1, so I minus 1. Okay, and for the right hand side it would be number of element right elements into current index, and here this one would be in negative, and plus we would have the post sum of n plus 1 position. Okay, so yeah, let's move to the code and see how we are implementing it most optimally. Okay, so in the code we see we have initialized the result array, and we are keeping a list of all the occurrences of the elements. Then we are storing the position of each element, and we are taking longs so that we avoid the overflow issues if we get in calculation. So yeah, so this occurrences map is putting all the indices with uh, elements with all the indices where they are present, and we are iterating over each element again, and if the size is 1, then the element is unique itself. It doesn't have any repetition, and we don't need to calculate anything there, so the index would be 0 at that position. Otherwise, if there are 2 or more elements, then we are getting the length. We are simply calculating the prefix sum and also the postfix sum. So this is the usual calculation that we do. And then for the indices, what is the index currently present, and what is present on the left side, what is present on the right side, number of elements on the left side and number on the right side, and the same formula that we are using for calculating the left portion of it and the right portion of it, and putting the value in the result. Yeah, this is a very interesting problem. Hope you liked the video. See you in the next video. Thank you.